Hello students and welcome to Geometry. Today we're going to talk about section 1.2, which involves points, lines, and planes. A couple of things that are important. One, knowing the definition and what each are is probably the most important. But at the same time we have to know how to name these properly when it comes to doing proofs in the future. So pay attention to both the definition and the ways of naming certain things. First definition, a point. Basically, everybody knows what a point is. It's a location. A lot of us think of it as just a dot in a space, but we have to recognize that it defines location. Any point you have can basically be anywhere on the paper, but it doesn't matter how big the point is. Alright, it defines location, not size. We represent a point with a small dot, and when we name it using a capital letter. Okay? Space. If we take all the points that we can create and put them all in the same area, alright, that would create space, and it's just basically the set of all points. Everything around us is made up of points, whether it's cells or molecules. Everything in space is a set of points. Now, when we take these set of points and we line them in a straight line, what we end up getting is a line. A line is a series of points that extends in two opposite directions without end. So when we look at a line, it's basically, you have this line and we put two arrows on the end because it tells us it goes in both directions without end. Our paper is not big enough to draw an infinite, line that extends in both directions. So we put the arrows on the end to show that. Now when we name a line consists of, the key thing about a line is to know that it's made up of an infinite number of points. Alright, which means there's so many on there, millions and millions and millions and millions. Alright, but in geometry, you'll generally only see anywhere from 2 to 3 to 4 points on that line. If I put these 2 points A and B on the line, when I name a line, I use 2 points, alright, and I put them back to back, but I have to put the line symbol above. This here is a symbol for a line. Now, the order of the points. When we name a line, order of the points does not matter. AB and BA are the same line. And even if we add a third point to the line, say C, I can name this line picking any of the 2 points. Never use 3 points, only 2. Such as line AB. You could do BA like we said. We could do BC. Alright, we can use CB. We can name this line many different ways using a combination of 2 points with a line symbol above. Now, all the points that lie on the same line are called collinear points. Now, when you look at it, 2 points. Okay? We could always draw a straight line through 2 points. So 2 points, one thing you have to understand is they are always going to be collinear. But in order for 3 or more points to be collinear, they all have to lie on the same line. So these 3 points would be collinear because they all lie on the same line. Now, if I look at these 3 points, can you draw a straight line through them? No. Those would not be collinear. So collinear points are points that lie on the same line. So looking at the first example here, use the diagram at the right to answer the following questions. Name 3 points that are collinear. Well, right now, if I look at this line here, this line has 3 points on it, D, E, and F. Since all of them are on that line, we could say that D, E, and F are collinear. If I look at the other line, I only see 2 points on it, not 3. H and E are the only points on the other line. Now, we want to name 3 points that are not collinear. Which ones do not lie in a straight line? Well, there are many combinations. Alright, if I look at D, G, and E, right, do those line up in a straight line? Absolutely not. Alright, another example would be H, E, F. Okay, I'll try to determine if you can find another combination of points that are not collinear. H, E, G. Those are non-collinear. So there could be a lot of combinations that end up not being collinear. Now a plane. A plane is a flat surface that has no thickness, and that's key to understand. If you hold a piece of paper up and you look at it, it's a flat surface with no thickness. We're going to be talking about intersecting planes. And when planes intersect, you have to know that they cannot grow thicker, alright, to intersect. These planes contain many points and lines, and they extend in all directions forever and ever. So although if I draw a plane up here, right, you have to imagine that it can extend that way forever and ever, that way forever and ever, that way forever and ever, and that way. The only thing it cannot do is grow thicker in any direction. Now, we can name it using a single capital letter or 3 non-collinear points. Okay, and we'll talk about it in example 2 in just a minute. So, coplanar. These are points and lines that lie on the same, or that are on the same plane. Thing about coplanar stuff, alright, is you have to see that you can extend it in every direction to see if they would be coplanar. There are going to be some examples here that will be difficult. Holding a three-dimensional model in your hand will make that easier, alright, but since this is a video, it's very difficult to understand that. We'll talk about that more in class when we go over this. So, we look at the plane down below, alright, it has 4 vertices. You have R, U, T, and S. We can name this plane using any 3 of those points with the word plane. So, I'm going to name it plane, and then I'm going to use a combination in order. Plane R, U, T would be one way to name it. I can name it using 3 other points. Sorry. Plane, say RST. Alright, and as you continue, you can go TSR, you can go RST, you can go STU, you can name it many different ways. Alright, but you'll also sometimes see a capital italicized letter that does not represent a point. If a plane has that, you can shorten it and just say plane Q. Okay, so you can only do that if it has that italicized capital letter that does not represent a point. Now, postulates and axioms. We're going to be dealing with a lot of these this year and using them. Alright, these are just an accepted statement or fact. These are basically like what we call common sense theorems. Alright, you probably already know most of them, but we formalize it in terms of a postulate or axiom. Okay, so the 4 we're going to deal with in this section. Postulate 1. Through any 2 points, there is exactly 1 line. No matter where you plot 2 points, it doesn't matter. You will always be able to draw a line through any 2 points. The reason we can only say 2 points is because if we draw 3, these 3 points lie in a straight line, right? But if I draw these 3 points, is there 1 line that can go through those? No. So that would not be an example. But this will always be true for 2 points. The second one, if 2 lines intersect, then they intersect exactly in 1 point. Notice, lines don't bend, they're straight. So when I look at this line and this line, they will only intersect in 1 point because they'll never bend around to intersect again. Postulate 1.3. If 2 planes intersect, then they intersect in exactly 1 line. You look at these 2 planes, right? This green plane and this purple plane, they all intersect in an infinite number of points here. But when you take all those points and line them up, they do end up being a straight line. So anytime we talk about 2 planes intersecting, you have to know that these planes intersect in exactly 1 line. And when you name that line, you have to name it appropriately. Line ST. Okay, so you have to use the 2 points and the line symbol. Then, Through any three non-collinear points, there's exactly one plane. When you look at 3 points, sometimes it's hard to imagine, but any 3 points will, 1, be coplanar, and 2, you will be able to draw one plane through it no matter what. Okay? I think 2 of the 3 are easy to understand. 1, 4 can be a little confusing, but as we go through example after example after example, hopefully you'll understand it a little better. So the first example 3 here are points E, F, and C collinear in this diagram. Well, if I look at E, F, and C, are these 3 points that lie on the same line? Yes, they are. Therefore, they are collinear. If I look at E, F, and D, E, F, and then D, do those lie on the same line? Absolutely not. Where does line M intersect line N? Well, if I highlight the 2 lines, so we'll take line N and line M. Okay? And by the way, I didn't mention that up there. Anytime you have these lowercase italicized letter, you can use those lowercase italicized with the word line accompanied with them to name a line if there are not any points given. So when I look at those, where do they touch each other? They touch each other right here at point C. Now where do line L and line M intersect? Well, if you follow them down, boom, boom, you'll see that they intersect at line or point E. Now they ask us, are point C and point P collinear in example 5? Well, looking at that, you don't see a line that goes through them. But before you answer no, you have to ask yourself, could I draw a line through those? And the answer to that is yes. So although you don't see a line drawn through them, 2 things you have to know here. 1, any 2 points will always be collinear. If they ask you if 2 points are collinear, you don't even have to look at the diagram. You should know 2 points will always be collinear. Now, if you don't see a line, if you can draw a line through them, that still could be yes. Alright, if you can't draw a line through it, if you were given 3 points, then they would not be collinear. So you have to know and understand that 2 points will always be collinear. Here, what is the intersection of plane HGFE? If I shade that plane HGFE, that's the top of the box here. Then I look BCGF. That would be this box here. Well, if I look at where these 2 intersect, they both share this line GF. Okay? Remember, anytime you're asked if 2 planes intersect, your answer will always be a line. Now, the next one, name the 2 planes that intersect at BF. If I look at BF, that is this side here, or line here. Well, if I look at the 2 sides, this side here, and we would name that plane EFB and plane, the other one that intersects there would be this one here, which is plane GFB. And remember, those could be named differently. Alright, you don't have to name it EFB and GFB. You could technically have FEA for the first one and CBF for the second one. Number 3, where does plane HEF intersect DAE? Well, if you look at HEF, that would be the top, and then DAE be this left side of the box. Well, where do they intersect? Well, the line they share is up here, which is line HE. Now, where does HD? And remember that there is a line. Okay, HD and AD, where do they intersect? HD is, we'll do a different color here. HD is here, AD is here, and if you look, they intersect at point D. You can also see that point is in both names. And the last one, where does HEF intersect plane AFG? This is where it's a little difficult. If I look at HEF, that's this plane here. But then AFG, alright, AFG, and let me do a different color. What you have to understand is that like slices through the box on a diagonal, and that's kind of hard to see. Alright, so you have to draw that plane in there, and I know this is hard to see because it's 3-dimension on paper. But when you look at these two, where do you see matching colors? Well, you see those colors intersect at line GF. Okay, so that one is probably the most difficult out of all of them. Okay, remember, 3-dimension when you're holding it in your hand is easy, but once you put it on paper, it's a whole new ballgame because it tends to be a little more complicated. Okay, example 5, plane points A, B, and C. If I look at A, B, and C, they would be on this bottom side. Okay, points E, H, and C. If I look at E, H, and C, you got E, H, and C. Well, there, it's not a side of the box currently, but if I kind of do what I did in the prior example, I'll notice it kind of goes on a diagonal through the box. Okay, that's a tough one. Alright, and C, where do EF and GF intersect? Well, if I look at EF and GF, where do they touch each other? At point F. Okay, so 3-dimension, again, on paper is difficult to understand. What helps generally is grabbing a diagram that looks like it and holding that 3-dimensional diagram in your hand, and it tends to make it a little easier. Alright, intersecting lines are coplanar. Would that be always, sometimes, or never? Well, I would say that's always, because if you take two intersecting lines, you should be able to draw a plane through them. Two planes blank intersect in exactly one point. Well, we just said a minute ago in the postulate up above, two planes intersect in a line. So if we need to name a line, can we ever get away with just naming a point? And the answer to that is no. So that would be never. 3 points are blank coplanar. Well, we said you need 3 points to define a plane. And if it takes 3 points to define it, and we set up above that 3 non-collinear points will be coplanar, well, 3 points are always going to be coplanar. When you get into 4, then it's a whole new ballgame. Okay, number 4. 2 lines blank meet in more than one point. Well, if you look at 2 lines, if they meet in one point. But what you have to understand is if I draw this line, could they potentially meet in more than one point if they are the same line? The answer to that is yes. So since we could draw 2 different scenarios here, this scenario being very rare, alright, you have to know that this would be sometimes. Alright, hopefully you'll be able to complete the homework now. If you have any questions, we'll answer them all in class, so just have them ready. Thank you very much. Have a good day.